Final exam review number 4. So this has got some probability and stuff on it. On your test, what am I going to ask for combinatorics? Probably a committee question or a card question, because those are my favorites. So here, a classroom consists of 8 males and 10 females. How many ways are there to form a committee of 7 people if it must have at least 5 females? Well, at least 5 females on 7 people, that really means 5 or 6 or 7. Now, this isn't a probability question. I'm not going to end up dividing by the total number of choices and getting a decimal. That would be if they said, what are the odds of? I just want to know how many ways. This is a job for a bucket. We have males and females. We have 8 and we have 10. So, if I have 5 females, I must have 2 males. Or I could have 1 male, 6 females. Or I could have no males, 7 females. I generally do these one at a time and then write down what the answers evaluate to. So 8, choose 2, and 10, choose 5, 7,056, or change that to a 6, change that to a 1, 1,680, or change that to a 7, change that to a 0, 120. Total, that plus 1680 plus 7,056, double check to make sure I haven't typed this in wrong, made a dumb mistake, 8,856. Committee question, with at least or at most. Probability question. So here's a conditional probability. I like this one because this is the one that may save your life. Population that a random member of the population has the dreaded disease Speckmanitis is 3%. The test for Speckmanitis is 95% accurate. Given that someone tests positive for Speckmanitis, what's the probability they actually have the disease? So we're going to have a couple of events here. We'll have event D, that you have the disease. And how about event P, that you test positive? First of all, the population either has the disease or it doesn't. 3% have the disease, 97% don't. Then you can test positive, test negative, test positive, test negative. If this test is 95% accurate, if you have the disease, you'll test positive 95% of the time, but 5% of the time the test will miss it. If it's 95% accurate, if you don't have the disease, you'll test negative 95% of the time, but 5% of the time you'll be called a false positive. What's this question asking you to find? Conditional probability. Given that someone tests positive, which is the bottom row, find the probability they actually have the disease, which is the top row. And this is going to be the probability of both of those divided by the probability of the given one. Which branch has both of those? That branch there. 0.95 times 0.03. Which branch ends in a P? This branch or this branch? .95 times 0.03 or 0.97 times 0.05. Can these cancel? They aren't factored. Don't you dare. Final answer. On the top, I'll have 0.95 times 0.03 divided by, on the bottom, I need brackets because there's more than one number, 0.95 times 0.03 or 0.97 times 0.05. Turns out there's only a 37% chance that you actually have the disease. You got a good chance of being healthy. 0.3701 or 37.01%. Let me just double check to make sure I typed that right. Yep, I did. What's the moral of the story? Get a second test. Or, if you hear somebody testing positive for a banned substance, wait till you hear the results of the second test. Other conditional probability questions I like. A bag of marbles, given that you got a black marble, what's the probability that came from bag A? That's a nice one as well. Or maybe a card question. Probably, you know what? I might even do a combinatorics probability with cards. That way I can ask combinatorics and probability. Oh, an exponential equation. Yeah, there's going to be one of these on your test, so this is good practice. Where is the x sitting? It's an exponent, so take the log of both sides. No shortcuts here, too easy to make a dumb mistake. Move the exponents to the front, brackets. Oops, how about I put the log in, Mr. Dueck? 2x minus 3 log 3 equals 2 minus 4x. Whoa! Pen acting haywire here. 4x log 7. Multiply in to get rid of brackets. 2x log 3 minus 3 log 3 equals 2 log 7 minus 4x log 7. Get all the x's to one side. I think the easiest way to do that is going to be plus this to that side and plus that to that side. I think you'll get this. 2x log 3 plus 4x log 7 equals 2 log 7 plus 3 log 3. Now what? How many x's do I have on the left? 2. How many would I prefer? 1. It would be wonderful if there was some kind of a grade 9 mathematical operation. Oh yeah, greatest common factor. Cool. And I'll get 2 log 3 plus 4 log 7 equals this thing. Final step to get the x by itself, divide. X is going to be 2 log 7 plus 3 log 3 all over 2 log 3 plus 4 log 7, which is going to be fun to type. Bracket 2 log 7, close off the log, plus 3 log 3, close off the log, close off the top, divided by bracket 2 log 3, close off the log, plus 4 log 7, close off the log, close off the bottom. I'm pretty sure the answer is 0.720. Of course, I can always check by being clever. I can go back to this first line, graph this as left side, graph this as right side, and find where they cross. I can go into my y equals, clear whatever I have. I can go 3 to the power of bracket 2x minus 3, close bracket. I can go 7 to the power of bracket 2 minus 4x, close bracket. Pick a view window. Usually I go zoom standard as my first guess. That's a 10 by 10 by 10 by 10 window. Do they cross? Yeah. Oh, right around there. Second function intersection. First curve. Second curve. Yes. 0.720. Yay! I'm right. However, if you just do that and write down the answer, I'm giving you 0. This is probably worth 4 marks. And I can't help noticing, I think it's 1, 2, 3, 4, 5, 6, 7 lines. You know what? I'll probably make it worth 3 marks, a half mark per line or something like that. I don't know. A trig identity. Oh boy, I can hardly wait. This is so fun. This is also a fairly nasty one. How would I handle this? Well, start with the uglier side. They're both ugly. You know what? I'm going to rewrite everything in terms of sine and cos. Tangent is sine over cos minus, since I have one fraction, I want everything to be a fraction, all divided by sine over cos times sine over 1. This is going to become sine squared over cos on the next line. This is sine x over cos x times sine x over 1 all over sine x over cos x plus sine x over 1. So sine x over cos x minus sine x over 1 all over sine squared x over cos x. And this one's going to be sine squared x over cos x all over sine x over cos x plus sine x over 1. Holy smokes, I'm running out of room here. I might have to go smaller. We'll see. Complex fraction. So I'm going to multiply this by, well, by something weird it looks like. Let's try that again. Cos x over 1 over cos x over 1. Anything good going to happen here? I don't know. Let's see. When I do that, in the first term, a cos is going to cancel. I'll get sine x minus sine x cos x all over sine squared. I notice, can I cancel? No, it's not factored. I do notice that there is a GCF that I can factor out. Yay! On the top, I can factor out a sine, which may help. Over here, I'm going to do the same thing. I'm going to multiply the top and the bottom by the common denominator, which in this case is cos x over 1 over cos x over 1. On the top, I get the cos canceling. I get sine squared x all over. On the bottom, what do I get? I get a cos canceling in the first term, so I get just plain old a sine x plus a sine x cos x. Now what? To be honest, now I need more room. So I'm going to go like this, and I'm going to go keyboard. Enter, 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 all the way down to the next page. There we go. Give myself a blank page. So now let's keep going from where I left off, right here. I notice in the top on the left side I can factor out a GCF. By the way, again, this is a nasty identity. The idea is you find the one on the test easy. Good luck, Mr. Dueck. Oh, sure you can. On the top I can factor out a GCF of sine. And I'll get 1 minus cos x all over, come on, sine squared. How many sines? Oh, can I factor? Can I cancel? It is factored. 1 sine on top, 2 on the bottom. One of these will cancel. Pen's acting up. And I get 1 minus cos x all over sine x. On the right, I can do the same thing. Whoop, too far. On the right, I can factor on the bottom a GCF. So I have sine squared x all over sine x 1 plus cos x. Can I cancel? It is factored. And I end up with this. Sine x all over. Now what? Well, as a last resort, especially if I have a, come on, pen, if I have a binomial denominator with no squareds, conjugate. What would the conjugate of this be? 1 minus cos. Hey, what's on the top over here? 1 minus cos. Ah, I'm on the right track. Multiply by 1 minus cos x, assuming I can get the minus sign to stay there. And same to the top. 1 minus cos x. What's that going to give me? Well, I'm going to leave the top factored as is for now. I'm going to leave it as sine x 1 minus cos x. The bottom, when I multiply, I will get, I just want to put a bracket there, I think I did, it vanished. My pen's really going crazy right now. Arg! On the bottom, when I FOIL this out, I'll get 1 minus cos squared. Hey, what is 1 minus cos squared from my formula sheet? I think, call me silly, but that is going to be come on, pen. Squared x. This is driving me crazy here. I may have to stop this recording. Anyways, I'm pretty sure I put that x there a couple of times now. How many sine? Oh, can I cancel? It is factored. How many sines on top? 1. How many on the bottom? 2. How many left and where? 1 on the bottom. Final answer. Holy smokes. 1 minus cos x all over sine x, which is what I was trying to show. Q E D. Pause the video for a second, see if I can fix my pen. Well, I've just scrolled down. You can see where all my marks are vanishing to on a completely separate page. Some kind of weird glitch is going on, but I'll work around it. Let's pause the video. Alright, let's try this again. I can't get rid of the glitch, but I'll just power through it. Prove the following identity. I think I'll rewrite this in terms of sine and cosine. I think this is also going to be a pretty tough one, a fairly yucky one. Cosecant. Let's draw a line down the middle. Cosecant. That's going to be 1 over sine x. And since it's a fraction, I want everything to be a fraction, and secant is 1 over cos x. Cotangent. Cos over sine all over 1 over 1 plus cos over 1. I got complex fractions, so here we go. Now this time I have a sine and a cos, so my common denominator is going to be sine cos over sine cos. But I'll put it over 1, I'll put it over 1. On the top, a sine cancels. I'll have a 1 times cos. No more fraction on the top. On the bottom, in the first fraction, nothing cancels. Plus, in the second fraction, a cosine cancels. I'll just have a sine left behind. And I notice I can factor out a sine, which I'll probably do on my next line. Over here on the right-hand side, also a complex fraction. Here my common denominator is just plain old sine over 1 over sine over 1. Multiply. Forgot to put the arrows in there. Let's do that over on that side. Here a sine cancels, and I'm going to be left with, hey, a cos x on the top. On the bottom, holy smokes, I think I'm done. Nothing's going to cancel. If I multiply this out, I'll get a sine x plus a sine x cos x. Top matches, bottom has a sine and a sine cos, a sine and a sine. Wow! Question really easily done. That worked well. Number 6, solve this giving the general solution. What did the general solution mean? That means don't go between 0 and 2 pi. It means find the angles in the first circle and then add multiples of the period. Ooh, ugly cousin, tangent multiples of the period will be pi. And the fact that it says answer accurate to at least 2 decimal places suggests to me that this will not work out to a special triangle. This factors into numbers that multiply to -6 and add to +1. How about tan x minus 3? Tan x plus 2 equals 0. I get tan x equals 3. Tan x equals -2. This is 3 over 1. I don't have a triangle with a 1 and a 3 in it. I got a triangle with a 1 and a root 3, but that's not what this is saying. This is -2 over 1. I do have a triangle with a 1 and a 2 in it, but not with a tangent that has a 1 and a 2. Both of these, I'm going to have to use my calculator. Let's make sure my calculator is in radians. It is. Here, I'll do a quick sketch. Tangent is positive, so I know that my angle is in these 2 quadrants. To find the reference angle, it's going to be the inverse tan of 3. And I'll go to 2 decimal places. I'll go to 3 just to be safe. Inverse tan of 3. I get 1.249. That looks good. That means that this angle and this angle are both 1.249. My first angle is 1.249. My second angle is pi plus 1.249. Pi plus that answer, 4.39. And that's to 2 decimal places, so that satisfies. Here, this root, tangent is negative, which means it looks like I'm here and here. Again, I'll find the reference angle by going inverse tan, but not of -2. I already used the negative to figure out where I am, of 2. I don't never find the reference angle of a negative angle. I get 1.107. Which means that this angle and this angle are both 1.107. It means that my first x value here is pi minus 1.107. Pi minus 1.107. 2.03. My second angle is 2 pi minus 1.107. That 1 there looks a bit like a 7, doesn't it? Let's make sure it looks like a 1. Two pi minus 1.107 5.18. Now that's the answers between 0 and 2 pi. To give the general solution, I would then say this. Mr. Dueck, why didn't you write x2? Why didn't you write x4? Tangent is weird. If it had been sine or cosine, I would have probably had to write x2 and x4. But you'll notice that if I add, if I bring the decimals back, if I add 1.249 to pi, which is what I'm stating in this statement, I get the second angle, the 4.39 already. Same with the 2.03. If I add it to pi, or if I add pi to it, I get the 5.18, 5.17. I've rounded off a little bit. So I wouldn't take marks off if you also wrote x2 equals 4.39 plus pi n, and x4 equals 5.18 plus pi n. It's just redundant for tangent. Number 7. First, let's hit save. Bag A contains 5 white marbles and 7 black marbles. Bag B contains 8 white marbles and 4 black marbles. A bag is randomly selected, and then a marble is randomly selected from that bag. A, find the probability of getting a black marble, and I'll bet you B is a conditional probability. I like this question, I like this question, I like this. Well, heck, I'm telling you basically what's on your final exam. I'm also waiting for this thing to finish saving before I start writing, because I think I'm overtaxing my computer. Looks like there's 2 events. Pick a bag, pick a marble. 2 events, that's a tree. What's my tree going to look like? Well, I got to pick a bag. Bag A, 50-50, 50-50. I could have had you roll a dice, and maybe if it was a 1 or a 2, pick bag A, which would make this a 2 out of 6 and a 4 out of 6, whatever. Then I can have white. Now I was going to use black, but I already used B there. I'll go with white and not white. White and not white. How many whites? 5 out of 12. 7 out of 12. How many whites? 8 out of 12. 4 out of 12. Find the probability of getting a black marble. That's that or that. What does or mean? Add. Getting a black is 1 out of 2 times 7 out of 12, or 1 out of 2 times 4 out of 12. Conveniently, this question does have a common denominator. It looks like they're both going to be over 24. Assuming I can erase this highlighter, which is turning out to be tougher than I want it. There we go. I'm going to get 7 plus 4 over 24, which is 11 over 24. Oh, nice. B. I think there's a B. Given that a black marble is selected, what's the probability that it came from bag A? Given that it's not white, which is the bottom row, what's the probability that it came from bag A? This is a conditional probability, which is going to be the probability of A and not W divided by the probability of not W. A and black divided by black. A and black is dunk dunk, that branch, 1/2, 7/12. Black, we actually just figured out. We said it was 11 over 24. Otherwise, I could calculate it. I end up with 7 over 24 divided by 11 over 24. How do I divide by a fraction? Flip it and multiply. 7 over 24 times 24 over 11. Hey, the 24s cancel, and I get 7 out of 11. That there is final exam review number 4.